In the previous session, we looked at what are inequalities and how they can be solved using the same rules as that for equalities or equations. So let's look at some examples. 2 plus 2x is less than or equal to 3. So solving this inequality basically means finding the value of x or values of x which will make this statement true. So just like in solving equations, we try to solve for x. So we have to get rid of 2 on this side. So minus 2, which means minus 2 on this side as well. We get 2 minus 2 plus 2x is less than or equal to 3 minus 2. We are left with 2x is less than or equal to 1. Now we divide both sides by 2 to get x is less than or equal to 1 by 2. Now how do we graph this? So drawing the graph. Solve for x. We have already done this. Mark the value of x on the number line. More specifically, if the inequality is less than or equal to or greater than or equal to, use a solid point. And if the inequality is less than or greater than, use a hollow point. Here we have less than or equal to. So we have to use a solid point. Basically, solid point means that point also is included. Now draw a ray starting from this point. Which direction? Because we do have two directions. If less than or equal to, a ray from this point towards minus infinity. And if greater than or equal to, a ray from this point towards infinity. We don't have to make it a very long line. We can just mark it with an arrow. That's why a ray. X is less than or equal to 1 by 2. And this arrow signifies that everything to the left is included in the solution for this inequality. Okay, now let's look at another example. 4 plus 3x is greater than or equal to 13. 3x is greater than or equal to 13 minus 4. 3x is greater than or equal to 9. X is greater than or equal to 3. So now how do we graph it? Again, because it is greater than or equal to, we put a solid point at 3. And since it is greater than or equal to, the ray goes to the right. Let's look at the next. 7 plus 3x is less than 6. 3x is less than 6 minus 7, which means 3x is less than minus 1, which means x is less than minus 1 by 3. And now here equality sign is not there. X is less than. So we use a hollow point to mark minus 1 by 3. And since it is less than, arrow goes to the left. Let's look at another one. Minus 11 plus 13x is greater than 2. See, this inequality may be given in any form. It might be given as 13x is greater than 2x plus 11 or something like that. So we ultimately have to simplify it and solve it for x. 13x is greater than 2 plus 11. 13x is greater than 13. X is greater than 1. So now again, 1 is not included. So hollow point. And greater than, so the arrow goes to the right. Now let's look at two additional examples where we will look at what happens when the inequality is multiplied or divided by a negative number. So we have minus 3x plus 7 is greater than or equal to 13. Minus 3x is greater than or equal to 13 minus 7. minus 3x is greater than or equal to 6. And now to get rid of this coefficient of x, we have to divide it by both sides by minus 3. So since we are dividing by a negative number, the inequality reverses. So minus 3x divided by minus 3 is less than or equal to 6 by minus 3, which gives us x is less than or equal to minus 2. Now graphing, same procedure we follow. Okay, now let's look at what happens when we multiply by a negative number. Minus x by 2 plus 6 is greater than or equal to 20. That means minus x by 2 is greater than or equal to 14. Now we are going to multiply it by minus 2, both sides of the inequality. So the inequality reverses, and finally we get x is less than or equal to minus 28. As we get larger numbers, it becomes difficult to plot the graph without rescaling the number line. So we will leave it that. So that was solving inequalities in one variable. That's it for now.